Hello dear students of 10th class, how are you all? First of all, welcome to all of you on my YouTube channel Physics Concepts and Motivational Talks. ਉਮੀਦ ਹੈ ਸਾਰੇ ਚੜ੍ਹਦੀ ਕਲਾ 'ਚ ਹੋਵੋਗੇ, ਆਪਣੀ ਪੜ੍ਹਾਈ ਵਧੀਆ ਢੰਗ ਨਾਲ ਕਰ ਰਹੇ ਹੋਵੋਗੇ। ਹਰ ਇੱਕ ਇਨਸਾਨ ਨੂੰ ਆਪਣਾ ਨਜ਼ਰੀਆ ਪੋਜ਼ਿਟਿਵ ਰੱਖਣਾ ਚਾਹੀਦਾ ਹੈ, ਗ੍ਰੈਟੀਟਿਊਡ ਵਾਲਾ ਹੋਣਾ ਚਾਹੀਦਾ ਹੈ, because there is nobody on this earth who knows everything and there is nobody on this earth who knows nothing. ਅਸੀਂ ਦੂਸਰਿਆਂ ਦੇ ਗੁਣ ਦੇਖਣੇ ਹੈ, ਨਾ ਕਿ ਔਗਣ, ਕਿਉਂਕਿ ਹਰੇਕ ਇਨਸਾਨ ਦੇ ਵਿੱਚ ਕੋਈ ਨਾ ਕੋਈ ਗੁਣ ਜ਼ਰੂਰ ਹੁੰਦਾ ਹੈ, ਉਸ ਗੁਣ ਤੋਂ ਆਪਾਂ ਸਿੱਖ ਸਕਦੇ ਹਾਂ। ਸੋ ਇਸ ਕਰਕੇ ਹਰ ਇੱਕ ਇਨਸਾਨ ਨੂੰ ਪਿਆਰ ਕਰੋ, ਰਿਸਪੈਕਟ ਕਰੋ, ਉਹਦੀ ਤਾਰੀਫ ਕਰੋ, ਕਿਉਂਕਿ ਹਰੇਕ ਇਨਸਾਨ ਚਾਹੁੰਦਾ ਹੈ ਕਿ ਮੇਰੀ ਕੋਈ ਨਾ ਕੋਈ ਤਾਰੀਫ ਜ਼ਰੂਰ ਕਰੇ। ਜੋ ਵੀ ਤੁਹਾਨੂੰ ਤੁਹਾਡੇ ਫਰੈਂਡ ਦੇ ਵਿੱਚ ਤੁਹਾਡੇ ਪੇਰੈਂਟਸ ਜਾਂ ਕੋਈ ਵੀ ਤੁਹਾਡਾ ਦੋਸਤ ਹੈ, ਰਿਸ਼ਤੇਦਾਰ ਹੈ, ਜੋ ਵੀ ਚੀਜ਼ ਵਧੀਆ ਲੱਗਦੀ ਹੈ ਤਾਂ ਉਹਦੀ ਤਾਰੀਫ ਜ਼ਰੂਰ ਕਰਿਆ ਕਰੋ, ਉਹ ਤੁਹਾਨੂੰ ਦੁਆਵਾਂ ਦੇਵੇਗਾ। ਔਰ ਜੇ ਤੁਸੀਂ ਕਿਸੇ ਦੀ ਤਾਰੀਫ ਕਰੋਗੇ ਤਾਂ ਤੁਹਾਡੀ ਵੀ ਲੋਕ ਤਾਰੀਫ ਕਰਨਗੇ। ਸੋ ਅੱਜ ਦਾ ਟੌਪਿਕ ਹੈ ਆਪਣਾ ਰਿਫਲੈਕਸ਼ਨ ਆਫ ਲਾਈਟ। ਸੋ ਫਸਟ ਆਫ ਆਲ, what do you mean by reflection? Now, when a ray of light AO is allowed to fall on a reflecting surface XY, it gets reflected along OB. Now, what does it mean by reflecting surface? Any polished surface is known as a reflecting surface. It reflects most of the light when it is allowed to fall upon that surface. And a silvered glass reflects most of the light falling upon that surface. So it is also known as a mirror. So mirror is a good reflecting surface. Now, the phenomenon according to which the ray of light is sent back into the same medium when it is allowed to fall on a reflecting surface is called reflection of light. So when light AO gets reflected along OB, and if ON is a normal, then this angle I, that is angle AON, is equal to angle BON. So this is called angle of incidence and this is called angle of reflection. So from this there are two laws of reflection. Number one, the incident ray, that is AO, the reflected ray, that is OB, and the normal ON, all lie in the same plane. Number two, angle of incidence, which is the angle separated by the incident ray with the normal, and angle of reflection, which is the angle separated by the reflected ray with the normal at the point of incidence, that is O. Both are equal. So angle I is equal to angle R. So these are the two laws of reflection. Question may be asked, state two laws of reflection. The first is incident ray, reflected ray, and the normal all lie in the same plane. Second, angle of incidence is equal to angle of reflection. Then we come to spherical mirrors. So reflection from spherical mirrors. So we have two types of spherical mirrors. One is concave mirror, other is convex mirror. So both these mirrors, basically they're a part of a sphere. Part of a sphere having center, say C. And this is known as center of curvature. In concave mirror, the inner surface is the reflecting surface and outer surface is polished. In convex mirror, the outer surface is reflecting surface and inner surface is polished. So in case of concave mirror, inner surface is the reflecting surface or it is silvered glass, and in case of convex mirror, outer surface is reflecting surface, that is it is silvered glass. So midpoint of mirror is known as pole of the mirror, P. C, that is center. C is known as center of curvature. What is center of curvature? It is the center of the sphere of which the mirror forms a part. So mirror is a part of a sphere. Then what is principal focus? Principal focus is a point where the rays after reflection from the mirror actually meet or appear to meet. That point is called principal focus. Distance between center of curvature and pole, that is CP. CP is called radius of curvature. CP is radius of curvature, capital R. And distance between principal focus and pole is known as focal length of the mirror. So focal length of the mirror. And a line passing through center of curvature and pole of mirror is known as principal axis. So these are some definitions before we draw image formation in case of concave and convex mirrors. I repeat, P is called pole of mirror, C is called center of curvature, F is called principal focus, FP is called focal length of the mirror, CP is called radius of curvature, and this diameter is known as aperture of the mirror. The diameter of joining the line from this edge to this edge is known as aperture of mirror. The rays of light which are close to principal axis are known as paraxial rays, and which are far away from principal axis are known as marginal rays. So these are some definitions that you must understand before drawing image diagrams. Now, image formation. First of all, we will draw all the image formation by concave mirror. There are 6 cases, because in case of concave mirror, the nature of image or position of image depends upon the distance of the object from the mirror. So first case we take when object O stands for object O lies at infinity, that is, object is far away. So then this is the concave mirror, P is the polar mirror. Now object lies at infinity means parallel rays are approaching the mirror. So when these parallel rays strike on the mirror, concave mirror, that is inner surface, whose inner surface is reflecting surface, then they get reflected back in accordance with laws of reflection. So they intersect at a point known as principal focus. So it means when object lies at infinity, image will be at principal focus. And since rays are actually meeting at F, so image is said to be real. When rays after reflection from the mirror actually meet at that point, the image is said to be real. So image is real, it is inverted, ulta hoega, and smaller in size hoega. That you will get, it will be clear in the next diagram. So when object lies at infinity, image formed is at principal focus. Simply you have to draw 2 parallel rays. So any parallel ray striking at the mirror will get focus at the principal focus. So nature of image is real, inverted, and smaller in size. Second case, when object lies beyond C. Beyond C means beyond the center of curvature. So suppose OA is the object lying beyond C, P is the pole, F is the focus, C is the center of curvature. You must know CF is also equal to FP. That is, radius of curvature is equal to twice the focal length of the mirror. So F is the midpoint of pole and center of curvature. So again you have to draw 2 rays only to make the image, minimum 2 rays. One ray parallel to the principal axis. The ray which goes parallel after reflection passes through the principal focus. Another ray which passes through the center of curvature is sent back, because when I is equal to R is equal to 0, it means ray strikes the surface, reflecting surface normally, it is sent back into same medium, that is, it retraces its path. So similarly, because this ray of light passing through center of curvature is normal to the surface, so ray passing through C will be reflected back. So these 2 rays, one parallel ray after reflection through F, and another ray which is passing through C and get reflected back, retrace its path. These two rays intersect at this point or meet at this point. So this OA dash, this is the O dash A dash is the image of object OA when object lies beyond C. It means in this case image occurs, image is formed between C and F. In first case image was formed at F. Now image is formed between C and F. That is between center of curvature and principal focus. Moreover, image is real because rays are actually meeting at this point. Inverted, you can see image is inverted and smaller in size. Size is small than the size of image. O dash A dash is smaller than the size of the object. Similarly, when O lies at C, now we are approaching toward the mirror. So we started from image object at infinity, then object beyond C. Now we come to the point C, center of curvature. Now when object lies at center of curvature, again we will draw two lines. One is parallel to the principal axis. So after reflection it passes through the focus. The ray of light which passes through focus gets reflected parallel in the backward direction. So any ray of light, if it is parallel to the principal axis, after reflection from a mirror, it will pass through the focus or appear to pass through the focus. And any ray of light passing through focus after reflection will get reflected parallel to the principal axis in the backward direction. So these two rays intersect at this point. So this is the image O dash A dash. So you can see this OA is equal to this. The size of object is equal to size of image. So in this case, image is formed at C. Real image is inverted and image is of equal size. So it means image depends on the distance of object from the mirror. Fourth case, when O lies between C and F. Again draw a concave mirror. This is the principal axis, pole, focus, center of curvature. Now object lies between C and F. We are approaching the mirror. OA is the object. One ray parallel passes through the focus. Another ray that passes through principal center of curvature is sent back or it retraces its path. So these two rays actually meet at this point. So O dash A dash is the image formed when object lies between C and F. It means in this case image is formed beyond C. Image is formed beyond C and object lies between C and F. Image is real because rays are actually meeting at this point. And image is inverted and image is larger in size. Size is more. Size of image is more than size of object. Now, when O lies at F, at the principal focus case, so when object lies at focus, ray parallel that will pass through focus, another ray that pass through center of curvature, retrace its path in the backward direction. Both these rays are parallel to each other. Means image will be at infinity. It means when object lies at principal focus of the mirror, image will be at infinity. So image will be at infinity. Then last case, when O lies between F and P. Very important case. So again concave mirror, object lies between F and P. OA is here. So we are approaching towards the mirror. One ray parallel passes through principal focus, another ray through center of curvature is sent back. Now these two rays are approaching like this. So but they appear to be coming, if you produce backward behind the mirror, they appear to be coming from this A dash. It means in this case, image will be formed O dash A dash behind the mirror. Which is very important case. So when object lies between principal focus and pole of the mirror, image formed is behind the mirror. And moreover, it is erect. It is upward, not inverted. It is erect. It is larger in size and it is virtual. So when object lies between F and P, image is found behind the mirror. Number 2, image is formed is virtual, erect and larger in size. So these are the 6 cases of concave mirror, how image is formed in case of concave mirror. So it is very clear that nature of image formed in a concave mirror depends upon the distance of the object from the mirror. Then convex mirror. In case of convex mirror, we have only two cases. First case, when object lies at infinity, rays are coming parallel to the principal axis. So they will get reflected as per laws of reflection. They will get reflected as per laws of reflection. But they appear to be coming from this point behind the mirror. It means image will be formed at F. This is not the principal focus. So when object lies at infinity in case of convex mirror, image formed will be at principal focus F and it is behind the mirror. It means it is virtual, it is erect and smaller in size. Now, last case, when O lies at finite distance from the mirror, at any finite distance, because in this case C and F lies inside. So it means there are two possibilities, either object is far away at infinity or object lies at some finite distance. Suppose O is the object in front of the mirror, one ray parallel gets reflected as per laws of reflection, appears to be coming from this point when it is produced backward. Another ray which join top of the object to the center of curvature. It is passing the center of curvature, so it is sent back into the same medium as per laws of reflection. So therefore, if we produce it backward inside the mirror, so these two rays are intersecting at this point A dash. So O dash A dash is the erect image of the object placed at finite distance from the convex mirror. It means it is very clear, whenever we have a convex mirror, image formed is always virtual, that is always behind the mirror. Number 2, image formed is always erect, सीधा होएगा, upward होएगा, and smaller in size होएगा. It is smaller in size. So this is all about image formation through concave and convex mirrors. So you can draw these diagrams, practice by yourself. So it is very simple. You need at least 2 rays after reflection to make an image. Now, from these diagrams, we can explain the uses of mirrors. From this diagram, what we see, concave mirror. So when object lies between F and P, image formed is erect and large in size, virtual behind the mirror. So this property, this of the mirror, makes its use as a shaving mirror. So concave mirror is preferred as a shaving mirror because when our face lies between F and P, image formed is erect and enlarged in size or behind the mirror. So we can see it clearly. So it is preferred as a shaving mirror. Moreover, these concave mirrors are used in searchlights, headlights. So reflectors of headlights are also concave shape and the bulb or tube is placed at the focus of the concave reflector, so that when we switch on the headlights, so light goes far away at longer distance. So it is used in searchlights and headlights of vehicles. This concave mirror is also used as objective of astronomical telescopes. So in astronomical telescopes, we use this concave mirror. There are so many uses. In ophthalmoscope used by doctors, so we use this concave mirror. So there are so many applications of concave mirror. Convex mirror. The main application of convex mirror is used as a driver's mirror, side mirror of any vehicle, car, scooter, motorcycle. That mirror is a convex mirror. Why it is preferred as a convex mirror is preferred as a driver's mirror? Because its field of view is large because its outer surface is reflecting surface. Its field of view is large. You can see the object from side. Number two, image found is always erect behind the mirror and smaller in size. That's why this convex mirror is preferred as a driver's mirror and concave mirror is preferred as a shaving mirror. So we cannot use concave mirror as a driver's mirror because in this case image will be sometimes inverted, sometimes smaller in size, sometimes larger in size, or it will be behind the mirror, sometimes sometimes in front of the mirror. So this cannot be used. This is used as shaving mirror in astronomical telescopes, in ophthalmoscope used by doctor, and in searchlights and headlights of vehicles, and convex mirror is preferred as a driver's mirror. So this is all about reflection of light in spherical mirrors and image formation and use of mirrors. So ਤੁਸੀਂ ਇਹ ਸਾਰੀ ਡਾਇਗਰਾਮਸ ਆਪ ਬਣਾ ਕੇ ਦੇਖ ਸਕਦੇ ਹੋ, ਦੇਖਣੀਆਂ ਜ਼ਰੂਰੀ ਹੈ। ਦੈਨ ਤੁਹਾਨੂੰ ਇਹ ਬਿਲਕੁਲ ਕਲੀਅਰ ਹੋ ਜਾਏਗਾ। ਮੇਰਾ ਸਿੰਪਲ ਟੌਪਿਕ next video I will share refraction of light and image formation through lenses. So till then, stay tuned.